Hi, here we have another question from Iran Mathematical Olympiad round number 1, year 1998. The question is to obtain a function with specific properties. So we want to find all function f from natural number including 0 to natural number including 0, such that for all value of n belonging to natural number and 0, we have this property f of fn plus fn is equal to n plus 3. First round of Iranian Mathematical Olympiad is usually consists of multiple choice questions. You get 30 questions for 3 hours. So approximately 6 minutes per question. Maybe spend 5 to 10 minutes try to solve this exercise and then come back and see the solution. The options that we have only one function, we have 0 function, 2 function, 3 functions, and infinite number of functions with these properties. Alright, let's look at the solution. So this is the general term that we have from the function. Usually when you deal with questions to identify a function or a polynomial, you must plug in small numbers into the function and try to extract some additional information. Okay, so this is the general properties that we have. I am going to put the value of 0 into this function. What happens? Then we have f of f0 plus f0 is equal to 3. We know that function f gets value of natural number including 0. So we have two numbers here that are belonging to this set, and the sum of them is equal to 3. That means f0 can be either 0, 1, 2, 3. Okay, so this is some additional information. And now we can evaluate f0 for each of these options and see whether we can gain additional information. Let's say that f0 is equal to 0. What will happen? So if f0 is 0, this is 0, and this one becomes 0, so f0 is again 0, then we have 0 is equal to 3, and that is contradiction. So therefore, f0 equal to 0 is not going to work, so this cannot be an answer. Okay, now let's say f0 is equal to 3. If I take this one, what happens? So we get 3 because f0 is 3, and here is f0 is 3, so f3 plus 3 is equal to 3. That means f3 is equal to 0. Now I'm going to put n equal 3 in this equation that we have. Okay, so we know that f3 plus ff3 is equal to 9 because 2 times 3 plus 3 is equal to 9. But we know that f3 is 0, so this is 0. And here is 0, so f0, we assume that it's 3. So in that case, 3 plus 0 is equal to 9, which is not possible because what we get here is that f0 has to be 9. Before we said f0 is 3. So this is not possible. Therefore, f0 cannot be equal to 3. We also eliminate this option. Alright, so far we said that f0 cannot be 0 and f0 cannot be 3. The next one is f0, for example, equal to 2. Let's see what happens. Okay, so this is the main equation that we have. If we put n0 here, we have this one. And now we assume f0 is equal to 2. If f0 is equal to 2, that means we put here, this is 2, 3 with 2 disappears. So f2 will be equal to 1. Okay. Now I'm going to put n equal to 2 in this equation. Let's see what happens. So f2 plus f of f2 will be equal to 2 times 2 plus 3, 7. But we know f2 is 1. Okay, so that means this one is 1 with this disappears. So we have f of 1 will be equal to 6. Now I'm going to put 1 into this equation. So if I put 1 here, f1 plus ff1 is equal to 5. But we know f1 is equal to 6. That means f of f1 should be minus 1. But this is not permitted because the function goes only to natural number including 0. It cannot get a negative number. Therefore, this is a contradiction. It means that f0 cannot be 2. So the only value that f0 can have is equal to 1. Okay, f0 is equal to 1. Now, we have these general properties fn plus ffn is equal to n plus 3. Obviously, one initial guess that you could have, if fn is n plus 1, what happens? This is n plus 1, here is n plus 1, it becomes n plus 2. So n plus 2 plus n plus 1, it becomes 2n plus 3. And that also matches with our finding about f0 because we said f0 is equal to 1, which is basically 0 plus 1. So if we assume that function fn is n plus 1, Actually, we can easily prove that this one always works here. So let's say if we have n plus 1 instead of fn, and here fn plus 1 equal to 2n plus 3, so you simplify, you conclude that fn plus 1 is n plus 1 plus 1. So the general function fn equal n plus 1 is actually a solution that we have. Okay? But the question is this fn equal to n plus 1 the only solution? Maybe we have some other functions that have the same properties, but we could not guess it right now. Okay, let's see what can we do. In these cases, what we have to do is to define another function gn, and then we are going to find new properties for gn. For example, here I define fn equal to gn plus n plus 1. Actually, whatever function that we found, I already added it to gn, and that one is equal to fn. So gn will be fn minus the function that we found. And I'm going to prove that gn is always equal to 0. In that case, we know that fn must be only this solution. So if we define it like this, we know that for 0, f0 is 1. So g0 plus 1. So g0 becomes 0. Okay, so this is straightforward. Let's now calculate the properties that is given to us. For example, ffn plus fn will be equal to f. Instead of fn, I put gn plus n plus 1. And instead of fn, I put gn plus n plus 1. And now this one, I'm going to calculate it again because we say that fn is this one. So f gn plus n plus 1 will be g gn plus n plus 1 plus the number that is here itself plus 1. So gn plus n plus 1 plus 1. And then we have also this one here, gn plus n plus 1. This one has to be equal to n plus 3 as we have it here. But you notice that here we have n, here we have n, 2n, and then there are 3 1s, so 2n plus 3. This one with this disappears. What we get is that g of gn plus n plus 1 plus gn is equal to 0. And we know that g0 is equal to 0. Okay. If you have these properties, now I'm going to put n equal to 0. We know that g0 is equal to 0. I'm going to put n0 in this equation. What happens? So this one, g0 is 0. This is 0. This is 0. So g1 will also become 0. That's a new finding. Now I'm going to put n equal to 1. So we know that g1 is 0. This one is 0. 1 plus 1, 2. g2 will be 0. And so we can show that for all value of n, gn is equal to 0. So if gn always is equal to 0, it means fn has to only be n plus 1. In that case, we prove that we have only one function, fn equal n plus 1, that fulfills these properties that is given in the exercise. Therefore, the correct answer for this option will be option B, which is one solution. Let's see what we have learned in this exercise. In the question that they ask you to calculate a function or a polynomial with the specific properties given to you, first try to evaluate the function at different input values and obtain new patterns. Use the obtained patterns along with the properties of the function. Try to identify the function. You can sometimes use mathematical induction to prove that the function you guessed is valid for all value of n. And finally, you have to prove that the solution you found is unique, or maybe you have to find other solutions that are acceptable and basically show that only these sets of solutions can fulfill the properties given in that exercise. Alright, so that's all for this video. I hope that you learned something new. See you next time. Bye.